Today we're going to look at how you can solve an algebraic equation through the process of substituting values. It's one of the common things that's given out in schools and colleges and universities whenever you are working through the process of substitution. And it's not just limited to mathematics. You may find it in statistics, economics, physics, chemistry, biology, even in nursing, even in computer science. Doesn't really matter where you are, you're going to find the process of substituting values in the formulas. Let's take, for example, the simple formula force equals to mass times acceleration. You got to multiply the mass and the acceleration to get the force. Now let's say if the value of m is 100 and the value of a is 60. So you are going to substitute in place of m the value of 100. In place of a, the value of 60. Now after the substitution process, I can write my numbers like this. 100 goes in place of m times 60 goes in place of a. That's one way of writing it. Some people may write out the same equation like this. Force equals to 100 times 60. Now whenever you drop multiplication and you put values in parentheses, the multiplication is implied. Some people may write the same equation like this. Force equals to 100 times 60. In all three cases, it means exactly the same thing. There is no difference. The answer will be very, very similar. Now, since we are working on this process, let me also teach you another math trick. As the answer will be the same for all of them, let's solve one of them. Okay? Now, there are two ways that you could literally pull out a calculator, punch in 100 times a 60, and you can write your answer down. The other way to do this multiplication would be by hand, where you write down 100 and you multiply it by a 60, and you can do this long multiplication. But we're going to take a short approach. The short approach is this. Yeah, this is very handy. Multiply 6 by 1. 6 times 1. What do you have? 6. And now you write down as many zeros after 6 as there are in the original problem. The original problem had 1, 2, 3 zeros. So I wrote 3 zeros out. Now, even if you pull out your calculator or do it the long way, you're going to get exactly the same answer. For example, this is the long way. 100 times a 60. Now, 0 times any number is a 0. 6 times 0, 6 times 0, 6. Then you add, see, I got the exact same answer, but I don't have to go through this long process of multiplication, especially when I'm multiplying something with tens or powers of 10. So anyway, this is through the process of substitution. Once you understand this, it doesn't matter you're substituting fractions, you're substituting decimals or whole numbers, the idea stays exactly the same. Now, let me give you one example that you may find in the books of algebra. A equals to x plus y. Somebody has to give you the value of x and y to be able to solve this equation. Let's assume x is 3 and y is 4. So you substitute in place of x 3, in place of y 4, and you get your answer 7. Now that's why algebra is considered to be the gatekeeper of the classes in mathematics, because when you start learning arithmetic, you generally see statements like these. A equals to 3 plus 4. So you add 3 and 4 and you get an answer of 7. But where is the basis? The basis lies in algebra. Once algebra creates an equation like this, a equals to x plus y, what does that mean? That means two quantities can add to give you a third quantity. Now that idea of two quantities can add to give you a third quantity could apply to billions of applications. You can add a subtotal with the sales tax total to give you the total. You can add a commission to the salary to give you the total salary. You can add the scores of first test plus the second test to give you your total score. So all of these are different applications that all are based on this one formula that two quantities are added to give you the third one. And the applications are endless, and endless applications are out there. So that's what algebra does through the process of substitution. Now, let me make a slight change here. Before I do that, let me once again introduce you to your PEMDAS. Please excuse my dear Aunt Sally. What does this stand for? These are your operators that you use in the order of operation. You have parentheses, exponents, you have your multiplication, you got your division, you got your addition, and you got your subtraction. So parentheses, multiplication, division, addition, subtraction, okay? And here's my exponent, right between multiplication and parentheses. Parentheses always is the highest, most precedence operator. Then comes exponents and square root. They're at the same level. Then comes multiplication and division. They're at the same level. Then comes addition and subtraction. Now they're at the same level. So now, if you are running into an equation like this, a equals to x squared plus y, based on the order of operation, exponents must be solved before the addition. So, if I have x equals to 3 and y equals to 4, I will substitute in place of x 3 and in place of y 4. However, I have to keep in mind that my x is an exponent squared, so I can't lose it. 3 squared is 3 times 3, which is 9, plus 4. Now that I'm done with my exponent, I will now going to do my addition. So that will be 9 plus 4, and that is 13. So that's how I was going to go about solving this particular equation. Now, in another set of tutorial, I'm going to talk about these in a little bit more detail. So before we move forward with algebra, you must be very clear about these PEMDAS rules.